So till now, yesterday we talk about how do we deploy custom application on Kubernetes. Then we spoke about how do we the PVC and PV. Now, today we are talking about Helm. Helm is all about the package manager for Kubernetes. So we went ahead and installed Helm to the going back to the official website of Helm and installed the Helm packages and ran it. In order to work with Helm, you need to have Kubernetes as a base on your backend. If you don't have Kubernetes, Helm will not make any sense because Helm is a package manager for Kubernetes. Okay, once we have run the scripts by running the command Helm version, we came to know that Helm 3.11.3 has been installed successfully. Okay, now Helm works mostly as an ad hoc command, guys. So you can use this command line tool of Helm starting with Helm itself, and you can work with Helm. You can do all the activities operations of Helm. So Helm will give you a complete list what Helm exactly does. Now see this. This is the available commands with Helm. Okay, it's for checking the release history. As I said, whatever deployment you do that consider as a release in Helm, you can list all the releases. You can list all the packages. Packages are nothing but chart. Your chart directory. The chart directory will contain packages. So this is pulling, pushing from remote repository. Remember Artifactory, which I showed yesterday? Adding repo, removing repo, everything can be done using command line. Now let's go to the official side of Helm from where you can go and get the packages. So this is Artifact Hub. Now, as I said, this artifact previously it was multiple sources from where we used to get the packages. Now all these sources came together and they have created a website that's Artifact Hub. And now you don't need to go on 10 different places. The packages, you can get all those packages into this single website. Everything is there in one location now. Okay. Previously it was Bitnami, it was Falco, it was many others. Now it is only one single place wherein you can have all the packages. Okay, you can even sign into this website and you can have your own private Helm package created and you can push your package in Artifact Hub also. These packages are mainly YAML files, guys. So this is mainly will contain your deployment file, service file, your secret file, config file, such files it contains, nothing extra, because that is what Helm does. It is just managing the packages for you. Those packages are from Kubernetes. Okay, so let's go and look into, I want to have something called Nginx. Now if you see, there are multiple sources. Bitnami, you got Falco, and you got Mirantis. So whichever you like, you can go. These are all sources from where you're getting the packages. Okay, now if you go into Bitnami, so this is what it is offering. And if you see this tick over here, this is a verified publisher tick. If you get this tick, so this has been verified by Helm, and you can go and use this particular package without any issue. Now if you go inside this and if you read through the package, so this is Nginx open source, is a web server that can be used as reverse proxy, load balancer, HTTP. Now I want to use this package inside my Kubernetes. I want to deploy a web server, Nginx web server. So the first thing you need to do is you need to go and install this package. Okay, how do we install? You can go to this install section. You can look into all the templates and everything, the value schema, everything over here. I'll talk about all these things in a bit. For now, if you want to install, go to this section. This is how you will add the repo URL first. You need to go and add your URL. The command is helm repo add. This is the local name on your system. So you can, once this URL is added, you can refer to this URL with this local name. Okay, and this is the URL which you're adding. Copy this, come back, run this over here. Okay, let's add this. Bitnami, if you see, Bitnami has been added to your repository. Now if you want Helm repo ls, you can see this URL is there right now. Now, if you want to install anything, like if you want to install Nginx, if you want to install any other package, and if Bitnami has that package, it will go and download that package for you. Okay. How do we install packages? Now it is very easy. Helm install. You can give your package name and name it as my Nginx. This is the local name how your release will be identified, and where exactly the package is. It's in Bitnami. So that is the name we have given, correct? That name could be anything, guys. What is the package you want? Nginx. Do you want any specific version? Like if you want to have any specific version, then you can define the version. Like what is the latest version? 14.10, if I believe. Yeah, 1.0. It's 14.1.0. Okay. Now what exactly this will do? It will download and install the complete chart. Now, what all things we have it in the chart? Let's see that. Before that, let me go and install this for you. Now, if you go and see, your Helm chart was deployed successfully. We have deployed it directly. We have not just downloaded a chart. We have deployed the chart as well with this command Helm install. Okay. The last deployed, status deployed, revision number. This is how Helm identifies which revision it is. Chart name Nginx, chart version 14.10, app version 1.24. Now what it is telling, Nginx can be accessed to the following DNS. If you want, you can go and access your Nginx web server using this DNS. And if you want to know the status, if you want to have you need to know the URL, go and check your services. See, all this got installed. Now if you go and run the command kubectl get all, see, you got this Nginx web server running. You got this load balancer type Nginx created. You got this deployment created. You got this replica set created by running one single command. By running one single command, you got everything created, up and running right now. Now, many of you will say, no, I need to do customization and everything. That is something we'll understand later. But for now, this is how Helm works. Now, if you want to know what all things you have, what is the revision, so which release is working right now, Helm ls will give you a detailed information. This is my Nginx. This is the chart which we are using. The version is 1. That's the first version, updated, deployed, and this is the Nginx version what we are using right now. This is how you will see the revisions. This is how you'll be seeing the revisions. Okay. Now this is a chart which we have deployed successfully. Okay. Now, if you want to know what exactly the chart is all about, so there is a command called Helm show, and in this you can have all. Which chart name you want to know? Bitnami. What is the name of your chart? Nginx. See, this is your complete chart. I know you will not understand by looking into this chart. You will not understand anything. Later, I'll download the chart and show you. See, this is a complete chart. What exactly is happening inside the file? This is the complete chart. Now, show if you want Helm show, and just let's do a help. There are other things also you can know, not just a complete value. The value file is very important, where the values are defined. See this value file. So let's do one thing. In place of all, let's do values. Now these are the values which is getting called. So how the naming convention, how my chart knows that I need to create a load balancer type service, how my chart knows that I need to have this naming convention use, this service type needs to use. All this information is stored in this values file. So the value file basically has all the schema. Based on this value file, the naming convention and the type and everything is used. Okay. Now if I go to the official website, now if you can see, this is the value schema given over here. It's all defined over here. Service type and everything. You can go and make changes, make amendment to it. Okay. Same goes with templates over here. You can see. So this is what it follows, guys. It follows Jinja to templating. Remember Ansible, where we have used Jinja to templating. Now you don't need to go inside this, understand what exactly is written. You just need to know if later, if you want to do any sort of customization, how do you do it? Okay. For now, if I want to access this kubectl all, for now, if I want to access this web server, how do I access? Because it's a load balancer type, so nothing we can do. We need to get this converted into a node port, then only I can access this particular web server. Okay, so what I can do, I can do edit kubectl, edit svc and my nginx. So what I'll do, I'll go and change the type. This is other way of changing, guys, in case if we have not covered this. I can go and change the type. Just make sure, just change the type, nothing else change. Change it and save it. What will happen? The svc will be recreated automatically. Do you see it got created? Now if you want to access this, I can just simply do a curl followed by port 80. Do you see my welcome to nginx? I'm able to access now. I can access this from outside world also now. Both the ways are possible. Now this is the package which you have directly installed. Now if you want to do any upgrade, like suppose there's a latest version of nginx. Okay, suppose there is a latest version of nginx which is there in the market and you want to upgrade your package. So in Helm can very easily can help you upgrade, roll out, rollbacks. This can be done very easily with Helm. So this is the package what we have right now. Now let me, if you want to upgrade, the command is Helm upgrade. One single command, guys, and it will upgrade everything. Now Helm will take care of everything in the behind the scene. So now for upgrade, whatever things needs to be done, like editing the deployment file, editing the service file, editing the replica set, editing the secret file, config file, whatever addition required, Helm will do it for you. In the backdrop, it will go and do that for you. You don't need to worry about how Helm is managing. Helm will do if you want to do any sort of upgrade. Like my nginx, this is the name of my release, and you want to do an upgrade. So I just simply do a bitnami. That's my repo, correct? So we need to give the repo name followed by the package, my nginx. See, done, upgraded. Now if I go and look into Helm ls, you can see the revision 2. Okay, now if I go back to Helm history, history will basically give me all the changes we did with this particular package. Now see this, superseded, deployed. So this was the previous one which we have initially deployed, revision 1. Then we got the revision 2. The only difference is the same chart, guys, because we just got, there was nothing to upgrade. But what Helm does, Helm will not replace. Like if I'll do a rollback, for suppose if I do a rollback, if I go back to the previous version, so Helm will not replace or Helm will not go back to this revision. It will create one more revision which will be replica of this revision if I am rolling back to the previous version. Like the way I have created a new version over here, if I'm rolling back, it will have revision 3 created and it will take my package back to this version. As if there's no difference because it's the latest version which we have downloaded. Like if I want to go back to any other version, I can see this. There is a version called 14.0.0. I can even downgrade, roll back to that version easily. Okay, if you want to know how is it done, if you don't remember anything, simply go to Helm help See this. Upgrade can also, rollback can also be done. Rollback a release to a previous revision. If you want to roll back to the previous revision, this can be done using Helm. If you want to delete your chart, what you have right now, so Helm, simply delete. Like this is the chart, correct? If you want to delete everything, Helm delete followed by name of your chart. Done. Now if you go and see kubectl, get all, nothing will be there. Everything got removed at once. Now, if you want to delete manually, you have to delete the deployment, delete the SVC, and delete all the related objects. Now, Help is considering this as one single object and deleting everything. Okay. Now, if you go and look into your Helm LS, nothing is there. History, nothing is there because there's no release which I can view the history of. There's no release name for giving. So there's nothing right now. Okay. Now this is the complete package which we have downloaded, guys. Now in the package, it was assigning load balancer type. No, and then I went ahead and edited it to node port, which I don't want. When I'm installing the package, I want it should create the service with my values. Like it should have a node port, and if I want to change the package name, if I want to change something inside it, I should have all the controls. It should not happen that Helm is installing the package for me. I should have the control, and I should be able to customize that package based on my requirement. If you have anything as such requirement, then what you can do, you can download the package locally first. Get that package downloaded on your local, go through the package, you will then understand what all things are there. Like let me have a tree tool installed first. So how do we download the package? For downloading the package, come back. This is getting you the complete package directly, which I don't want. Let's go back outside. Look for Nginx again. Yeah. Let's go to install. Okay, it's not giving me option to download. Okay, forget about it. Let me show you how do we download this package on my local. Okay, the command is you can pull the package. The command is helm pull, and you can give the package name. That's Bitnami Nginx, correct? That is the name of the package. Bitnami is the local repo because we have the local repo right now. Helm repo. We have this Bitnami. So basically, if you're giving Bitnami, that means you're giving this URL, and basically I'm giving this URL. Okay, and name of the package Nginx. Now, if you download the package like this way, what will happen? You will get a tar file. So you need to go and untar it. Then you will come to know what all things are there inside that file. Or if you want, while pulling, there is a flag which you can use, untar. So this will not go and install the package. Unlike the previous time we did, we went ahead and installed the package directly. This will get you the files. Now this is up to you. If you want to go and make some customization, make some changes to that file, you are free to do it. See, now if I want, I can do a ls. Do you see this? Get helm dot, sorry, you see this Nginx drive? Now if you go inside this Nginx, if you do a tree command, see there are so many YAML files. There are so many YAML files. So Helm, this is what Helm does for you guys. You got all the template files. In the template file, you got your deployment, the important files I'm talking about, the deployment.yaml file, it got your service.yaml file. Now if you go up, you got the chart lock. This is how Helm locks your chart, that this is the version of chart which you have downloaded. Those informations are there inside this lock. This is your chart.yaml file. This is your actual chart, wherein you can define your storage if everything is there. For validation, it also got multiple other things. For template, it got your helper, deployment, Ingres, Prometheus. It also, if you want to enable Prometheus for this monitoring, you can do that with Helm. Service monitoring, SVC. So there are values. This is very important file, guys. Value.yaml file. This folder templates and value.yaml file. Basically, Helm is installing everything. All the values are defined inside this values.yaml file. Now, if you go and look into, let's go and look into the template file. Let's go into CD templates, and in this, let's open the deployment file. This is how the deployment file looks. So basically what is happening, if you look into the API version, where it is referring to, it is using the Jinja 2 templating. This two curly braces, what you see, it's a Jinja 2 templating. Now it is getting the, basically it is getting the values from this place. Common.capabilities.deployment. So there is a folder called common, and there is a file called capability. In that there is a tag called deployment, and from where it is getting you the API version. Okay, I'll show you how to read through this file. Now let's go back. Let's open the SVC file. That's your service file basically. This svc.yaml. Now in this svc.yaml, you got the API version, you got the kind, you got the metadata. From where it is reading the metadata, see the values from common.name.fullname. Now let me give you type. Now if you come to the spec section, do you see the type? The type is given as dot values. So there is a file name dot values, and then there is something called dot service dot type. This is from where the type is defined. Okay, let's go and look into this file dot values, where exactly the type is defined. Now if I come down, come outside, now this is the place where you will find the value file. This is the file, value file. Open this file. Now it was service inside values dot service dot type. That is how it is defined. Now if I come down to service, where is service? See the ports and everything for Nginx, it's defined over here. So this is what it's getting called inside your deployment.yaml file. Where is service? This is service account. Value service.metrics, service context. So there is, wait, let me come out of this. Let me do a cat values.yaml, do a grep, and just look for this term dot service. Oh my god, there are so many places. Okay, so in this, it should be service dot type. See service dot type. Let's open the file again. So it is the image from where it is exporting the image. Let's do this way. It should be load balancer. See this over here. Now, do you see this service? The service is defined over here. So this is how the name reads. The file name is values dot service dot type, and over here it is defined as load balancer. Okay. If you go to the deployed your svc.yaml file again, how the type is getting called? Dot values. So that is the name of the file. Dot values dot service and dot load balancer. Now, if you want, you can edit this file. Go and edit this and change it to noteport. If you want to do this customization of changing the package name, you can do that way. Or else, if you want, while running this file, while executing this now, because you have got this package downloaded, by executing, you can you can change the values during the runtime. How exactly this can be done? You can do this with Helm install. Now I'm installing it from the package which I have downloaded. Install, and then I can have something called set. Now what exactly I want to change? I want to change service.type. So it is values.service.type. So while setting it, you can just have it as service.type. Okay. And now either over here, I can just give it as noteport. So what will happen? The value will change from load balancer to noteport. And I just give the name of my release. That's my nginx. And where is the file? The file is right over here. What will happen? It will go and get me the right thing created now. If you do this kubectl get all, you will see a svc created of type noteport. Now I don't need to do go in editing and all. So this is whatever you want to change, you can do changes at the values directly. Now this is one way of setting. Other way of setting, you can create a YAML file, guys. You can have a YAML file created. For example, I just have a custom, let's name it as custom dot values file created of your own. Okay, and in this you can define what you want, service type, correct? Service dot type. This is one example. This way you can change everything, guys, and you can have this as noteport. Now in place of set, what you can do, in place of set, you just have to give this file name. Just change this, change it to values, and remove this part, because there will be a possibility that you may have 10 different values which you are changing, correct? So defining this as a set will be a very clumsy task. So it's better to have it in a separate file, then call that file, and just let's give a different name to it, web nginx. See, done. If you do a kubectl all, do you see why it is load balancer type but didn't take that values? Did we do any typo? Custom values.yaml value should be YML. Wait. Service type noteport. This looks good. Service type noteport. Service. Okay, it should be equal to noteport, guys, not semicolon. That's why it didn't took it. Let me go and delete the release, Helm release. Helm ls. Releasing is pretty easy. Helm, delete, and uninstall. Everything whatever you have installed, this will get uninstalled. This is how you will be working with all these packages, guys. Now, what else in Helm? If you want to see your URLs, you get all your URLs over here. If you want to log in, if you want to have a custom package created for yourself, you can do a Helm init and it will go and create the custom package, and you can add all your YAML file by yourself if you want to do that way, that you're creating your custom package and you're creating your own deployment file, your own values file and everything. If you want to do it by yourself, you can do it, but for doing that you need to have a better knowledge of Jinja 2 templating. You should know how the Jinja 2 templating works. Based on that, you can do the same. Okay, same way you can have all the packages installed, downloaded, like whatever packages you think of, like you want Apache 2. See, you got Apache, you can go and install Apache. This is a different URL now. You can go and get this Apache installed. Now this is getting installed from this repository. So you need to go and add this repository first, then you can go and install Apache on your system. This is for Helm 3, Helm 2. If someone is using Helm 2, this is the command for Helm 2. Helm 3 and Helm 2 is drastic change, guys. So if anyone is using Helm 2, so that's a very pretty old version what they're using. Helm 3 is something very latest. Okay, so this is the way how you will be managing all the packages in Kubernetes. Now Helm will be managing this all for you. You just need to run single commands. Okay, so the hard work comes when you want to do customization to the packages. You can download the package, read through the package, understand what the package is, understand your requirement, and then go and start making customization in the Helm template basically. Understood? Anyone has any question, any doubt? Please do let me know. And don't worry about these commands which I have executed. I'll get a notepad created and I'll share that with you guys. Okay. Anyone, any question, any doubt, guys? Kindly let me know if there's any doubt, any question with Helm. So Helm is not a big tool, guys. Try and understand that it's a pretty small tool, but it does big task. It is managing the complete Kubernetes deployment for you. By running one single command, you can deploy your changes and you can roll back your changes. You can upgrade your changes. Everything can be done by one single command. Now, my one single pod was getting created, so even the replicas are defined in the values. If you go and look into the replica count will be deployed in the values.yaml file. If you want to change the replica count to something else, you can even do that. Okay. Whatever name change, naming convention change, anything you want to do, you have to download the template, go through the files, edit those values. If you don't want to change, you can even set it as set and you can run your chart post that. Any question, any doubt, please do let me know. If nothing, then we can move on to the next topic. That's Istio service mesh. Anyone, any doubt, guys? Srisha, NM, Josh, Adi?
I had a question, but I'm guessing you're probably going to address it. I was going to ask about endpoints for applications that we're deploying in the clusters. I'm guessing that might be something you still touch base on.
Correct. So, no, could you please repeat yourself again, like what exactly? Endpoints?
Endpoints. So, for example, whenever you deploy an application in a cluster, I'm guessing in the real world situation, you'll want to secure a particular endpoint for users to be able to access the application.
Okay, so in real world, you need to have if you want to have such thing endpoints defined, so you need to have, so there is a DNS mapping which is already happening inside your Kubernetes. Remember, we have installed VNet, the core DNS. So basically it is all whatever services, objects you're creating, it's already getting an endpoint created. Okay. But if you talk about real world scenario, so you need to have domain name assigned to it firstly. Like if you want to access your application, you need to have that domain name followed by the module name. That is how the endpoint, the URLs will be created. Now, endpoint basically you're talking about accessing the application from outside world, or you're talking about the internal communication?
From outside.
Yeah, so that's a domain mapping which you need to do. You need to have a domain name for that. You need to do the domain mapping. Post that, things will be, you can access this from outside world. Now, as if now I can do the domain mapping with my URL also. We got the URL. So we are already accessing it with a public IP. If you have seen noticed, we are accessing our application using public IP from outside world. Now, if you want to do a domain mapping, then you need to have a domain name for that. Or you can, if you want, you can have a domain name given what Azure provides by default. That is also something we can go ahead and give it.
Got it. Thank you.
No problem. Hopefully that was the question. Right.
Yes.
Yeah. If you want, you can configure your domain name. It's not configured over here. I can go and configure and select random domain names, but this will be a .eastus.cloudapp.azure.com. This is something in reality we don't use it. What do we use it? We'll have, like, suppose we'll have some name like amazon.com. So if you have a module with amazon.com, like you have created a finance module, it will be finance.amazon.com. That should be the endpoint. So that is how, if you want to do a domain mapping from outside world. Internal communication, so there is a DNS service in Kubernetes which takes care of internal communication. If you have seen, when I have installed Nginx, it was giving a domain name to me, that how the internal communication will happen, how you can access. See, the DNS name is given, webax.default.svc.cluster.local. This is how it is if you want to do any sort of internal communication. So this is a DNS name. So this is not for just Helm, overall Kubernetes. This is how Kubernetes reach through the services and everything inside Kubernetes cluster. Okay. So that was all about Helm, guys. Helm is not a big tool. I'll request go through Helm and let me know if there's any doubt, well, this is what you will do. You will be installing packages, you'll be downloading packages, you'll be making changes to the value file. That is what you will do when you're working with Helm. Okay, now coming back to the next topic, that is Istio. Now, what exactly is Istio? Anyone has any idea about Istio? Any vague idea what could be Istio? No one? No. Have you heard the word Istio before? Prior to this, guys?
How do you spell that?
It's ISTIO.
I don't think I have, but if I was gonna make a guess, it'd probably be some type of service mesh networking protocol.
Perfect. Yes, definitely it's a service mesh protocol. Now, what exactly is service mesh now then?
It's a, I believe it's a complex networking protocol. That's as much as I know.
Yes, that is right. So a service mesh basically, where is my PPT? Just give me 1 minute. Okay, a service mesh is basically, it's a dedicated infrastructure layer. What exactly it does? That controls service to service communication over a network. So what this method helps, a service method helps, it will help separate part of your application to communicate with each other. So this is basically used mainly at the container level. This is basically used mainly at the container level, pod level. Why? Because there are so many pods what we create nowadays. Okay, you have, and those pods are communicating with other pods outside the node. Now you have to make sure, now this becomes a very difficult network topology to manage. Okay, in reality, when you go in reality, and when, just imagine you got 100 pods running, 1000 pods running, and they're communicating with each other. You need to make sure that the communication which is happening, those communication is encrypted between this. This is where service mesh comes in picture. Okay. Now the communication which is happening, that communication needs to be encrypted. That is what service mesh is all about. Now let's understand in a very layman term. Let's imagine this is your cluster, one worker node. In this one worker node, you got your pods running, you have your web servers running. Imagine this is a second worker node, you got your database running over here. Now this communication should be encrypted, and this communication should also be encrypted. So from outside world, whatever traffic you're getting, okay, then even that should be encrypted. You're getting the traffic, you have your SVC over here, that's your service. Let's suppose, imagine that's a load balancer type SVC you're using over here. So you're getting your traffic over here on this load balancer, and then from SVC, the communication which is happening with your pod, that should be encrypted. Now how this gets encrypted? With the help of service mesh. Okay. Now what is Istio? Istio is a tool which provides you with service mesh capability. Istio is a tool which provides you with service mesh capability. Now Istio, what Istio does in a roughly, I'll tell you, because I'll be showing you the Istio architecture. Istio, what it will do, it will have some kind of network proxy in between. Istio will have some sort of network proxy in between. So now what is the work of this network proxy? It will take all your unencrypted request, it will process that request, it will encrypt that, then it will send it to the pod. So the pod, the traffic, whatever pod is receiving, that is encrypted now. In between, Istio has got his middleware in between, that's a network proxy. The work of that network proxy is nothing but to encrypt all the ingress traffic. Make sense? And this encryption is basically TLS, MTLS, what we use it over here. Now this is on an overview side what Istio exactly does. Now let's go back and see what is Istio. Not just encryption, it does many things, guys. So Istio is an open framework for connecting, securing, managing, and monitoring microservices. Now this is basically this, all this what I'm talking about, this is for microservice world. Okay. So at a very faster rate, we are moving into microservice, and there are so many services and things what we launch. Okay. There are so many applications nowadays we deploy on pods, containers. So those services needs to be secure. Okay. And those needs to be monitored. Now, what all things Istio does? It will do discovery, service discovery. It can also do load balancing. For these are additional features of Istio. It can do failure recovery. It can provide you with telemetrics, which you can later go and monitor as well. So all those metrics will be provided by Istio. Later we will be using this metric and will be integrating with Prometheus and Grafana, and will be integrating with Kiali. So these are all monitoring tools. Basically all these monitoring tools will help you monitor what exactly happening. So you can be, what we will do, we'll have a two-tier application deployed on Kubernetes. I'll show you what that two-tier application is. We'll have one Spring Boot application in the front end, and in the back end I'll have a Node.js. Why exactly I'm doing? Because I just wanted to show you the connection between those two applications. Then it can also help you with monitoring. Istio can also help you with complex operational A/B like testing if you want to do. canary release if you want to do, rate limiting, dark launches, access control, end-to-end authentication. So this part also we'll see how this authentication. So there's a term called peer authentication. That is something we'll see. Main important part is with Istio. What makes Istio unique? There is no change in code base. For doing all this, like, so you are adding a encryption method in your application without making any changes to the code. You don't need to go and touch the code base. You don't need to do anything as such. It will run as a sidecar container. Now again, coming back to the point, sidecar container, remember. Now this network proxy which I was defining over here, basically the network proxy will be inside. This is your pod, and inside this pod there are two containers. This is one container which is running a web server. So imagine it's a Nginx. Now in this container, it's in this pod itself, you'll have something called over here one more container. This container is nothing but it's your network proxy which Istio has provided. Now all the traffic coming inside will go to this first, get encrypted, then it will go to your web server. Then again, if the web server sends a response to this, then it goes outside. This is how the flow will happen. This is what sidecar container is. Now this sidecar container is doing multiple things. It is, firstly, it is providing you the secure connection. It is encrypting the traffic. Secondly, it is getting you the telemetry data, which can be later used for monitoring purpose, which can do the health check, health probe. It can check if the pods are healthy or not, if the application is healthy or not, if there's some issues with their application. All these checks can be done using this tool. There are so many other things also what Istio does. That is something we'll talk about later. But main important part, Istio has no code change. Okay. Now this is how, so the diagram is the rough diagram which I showed over here. This is how the diagram looks like, guys. This part is called pod. This is pod. This is the network proxy. This network proxy is known as envoy proxy. This is again envoy proxy. If you go and Google it, envoy proxy itself is a tool. Now Istio has done a collaboration. Envoy proxy is a very known network proxy tool in the market right now. It's very known. So what Istio does, Istio has integrated envoy proxy in Istio itself. This was a separate tool, envoy proxy. It's a separate tool which works at a network level, which is making sure all the network traffics are encrypted. Now Istio has done smartly. It has integrated this envoy proxy. There are other proxies also what Istio support, but envoy proxy is the default proxy what you will get. Now Istio, if you see mesh traffic, the mesh traffic is encrypted using MTLS. See the communication, this is encrypted. Now all the traffic goes to this proxy first, then the traffic goes to your actual web app. Then it goes to proxy again, then it is diverted. If you want to divert it outside, or if you want to divert it to any other backend pod, then again that communication is also encrypted. Now Istio is divided into two parts, data plane parts and control plane parts. Data plane, so data plane is basically implemented in such a way that it intercepts all inbound and outbound traffic from services. So basically you will have a service created, SVC created based on, so it is placed in such a way that all the traffic which is coming from your whichever service type, whether it's a node port, load balancer, whichever service type you're using, it is intercepting all the traffic in between. Now this control plane, basically these are the services which is running inside the control plane, Pilot, Citadel, Galley. So what exactly control plane does, the main responsibility of control plane is, it's to enable secure access and communication between service in a policy driven way. So that is what control plane does for you. Okay. Now what this pilot is, in control plane there are three important components. Pilot is, again, you can consider this person as the captain of your ship. Okay, so what exactly it does, it will handle all the configuration and programming of the envoy proxy sidecar. So all this envoy proxy, what you see over here, all this configuration and programming is handled by this pilot, this guy pilot over here. He's handling all the configuration and programming for the sidecar container. Some of the responsibility of a pilot container, if you want to know: observing the service topology, traffic shifting, fault injection, requesting routing, so many things it does, mirroring, so many things it does. Okay, now followed by we got something called Citadel. Now what this person does over here, so Citadel basically gives you keys and certificates to enable secure connection. So this particular service which is running, so when you install Istio, you will get this data plane and you will get this control plane, and along with control plane, these are the services which you will get. So Citadel is responsible for providing keys and certificate for secure communication, for securing connection between services. So that is what Citadel does. It also provides strong service to service and end user authentication using MTLS. So this mesh traffic, what you see, this is also Citadel is making sure it is providing end-to-end authentication using MTLS. MTLS is nothing but it's a mutual transport layer security. On the other side, the galley is nothing but it's a core responsibility is to distribute configuration input to other Istio components. So this guy is writing all the Istio configuration. So it's like a gallery wherein all the Istio configuration is written, and then this configuration is pushed and sent towards other Istio components. So these are important. Pilot manages the configurations, Citadel manages the certificates and key, Galley stores the Istio configuration and then pushes it to other Istio components. And this is nothing but this guy is network proxy, that's envoy. Network proxy responsible for intercepting communication and applying policies. Whatever policies you have set, it will intercept those traffic, and based on the policies you have set, it will go and allow the traffic. Okay, this is how traffic management is done in real time. Now Istio, you will be finding this Istio services on many VMs, in many companies at the production level. So this is something which is getting used widely, guys. Okay, and wherever you see this word service mesh, just keep in mind that service mesh is nothing but it's talking about the network routing which is happening for your microservice application. Service mesh provides you network proxy, and it is intercepting all the traffics coming inside, going outside, and based on policies, whatever policies you have defined, based on policies, the network is allowed, the network is denied. How you create a VM, you got inbound traffics rule. If you allow port 80, then only you will be able to access port 80 from outside world. If you deny port 80, what happens? You'll not be able to access. So not like that exactly, but at somewhat similar line. Okay, are we good with Istio? Anyone? Any doubt? Any question? Today I'll show you how do we set up Istio. What is the time? We got 15 minutes now. Okay, so today we'll see how do we set up Istio and how do we inject sidecar container. Those things we'll see today. Okay, anyone, any doubt with this Istio? Any confusion what this Istio architecture is all about? Any doubt with this Istio architecture, guys? No doubt. Let's go to the Istio installation. So let's getting started. Now how do we set up Istio? Again, Istio needs to have a base of, the base should be Kubernetes. Without Kubernetes, Istio will not work. So just keep that in mind. Now this is how Istio will be downloaded, guys. Copy this command. Again, a package. Get it installed. Now we got the Istio file downloaded. If you go and see, we got Istio. Along with it, once installed, set this path. Before that, let's go inside this package and let's set this path for Istio client. Okay. Once this is done, this is the commands which you need to execute. Istio install set profile demo. So there are a couple of profiles. There are 3 types of profiles which you will come across. Demo is one of the profile. Now what is the benefit of demo? Let's go and see. Let me copy this command first and let's change the profile. See, there are 3 types: default, demo, minimal, remote. If you come down, if you see, there are not 3 types, there are multiple types: default, demo, minimal, remote, empty, preview. Now if you have what we were downloading, we are downloading Istio demo. Now if you see, Istio demos has 3 components. It got Istio Ingress gateway, Istio this gateway, and Istio D. Basically this is the complete architecture. What you see, ingress traffic, egress traffic, and Istio D is basically this control plane components. So with demo, we are getting the data plane components, that's your proxy, and as well as the control plane component. That is what we are getting with demo. By default, you just get Istio D, that's your control plane component, followed by ingress gateway, only inbound traffics, no outbound traffics. Okay. So that is the reason we are getting this demo thing. Now demo, if you read the definition of demo, configuration designed to showcase Istio functionality with modest resource requirement. Okay. Boom. Basically, in reality, you'll be using the default one, wherein you'll be encrypting all the ingress network traffics. Okay. Now this is the command which I need to go and execute. Istio install. Now what Istio will do? So there are multiple things will be installed. Firstly, Istio will go and create one additional namespace with Istio system, and inside that it will get you all these components: pilot, citadel, galley, proxy, all these components. Do you see this? Istio D install. Istio D has all the control plane components. You got ingress gateway install. You got ingress gateway install. The installation is completed. Istio core installed. Now, how do we verify? You can just simply do kubectl, get all. You have nothing inside it. So this is your Nginx which we have installed with Helm chart. Let me just delete this. Nothing. Okay. Now where exactly it is? If you go and look into kubectl get namespace, you'll find there's one more namespace created 77 seconds ago. Now if you go inside this namespace, kubectl get all -n and Istio system. Do you see this? Istio D running as a pod. The services are running. Everything is running. So this is how Istio gets set up by running one single command. You can also set up Istio using Helm, guys, if you want to set up Istio. Now this is the Istio which is currently running on your system. Now let me give you the use case. How do we test things? Let me explain you the use case basically. That how do we verify if the networks are encrypted and how do we monitor those things. So the use case will be, let's go to very top. Where is the diagram? Just a sec. This is the use case. We'll have two applications installed now. This is a Spring Boot Maven application. This is the same application which we have done use during the CI/CD process. If you guys remember Java Maven application, this is the same application. Along with, I'll have Node.js application. Now, we'll have three modules inside that. One, we have incremental module inside my Java application. The second, we have compare module. Third, this is my home page. Okay. Now, when you go to the home page, it will basically give you welcome to DevOps course. That is a simple message what it will be displayed. When you do a compare, it will do a comparison with 50. Like if you have 51, that it will give you an output less than 50. If you have 49, more than 50, that is the message which you get. This is also very simple. There is nothing happening at the other side. This is getting displayed from your Java Spring Boot application. This third module now, incremental module, what it does, if you put 99, like for example, if you're putting 99, it goes to Node.js. See this, it goes to Node.js, and the calculation is happening over here at this particular application. It is adding 1 to it, plus 1. Then the output is sent to Java Spring Boot application. Then the response is sent back to us outside. Why exactly such complicated application I'm showing you? Because then only you'll understand the encryption method which I will set up with Istio, and the sidecar containers which I will be providing to these applications. You will then you will see the flow, how the flow gets encrypted. This is what we will be setting on Kubernetes. This thing what you see right now, this is something we'll be setting up things on Kubernetes cluster, post which we can work with it. Understood? And anyone has any doubt what exactly this flow is? This is a two-tier application, guys. So whatever experience you have till now with Kubernetes, based on that experience and the Docker experience, so this is these all applications are already created as an image, and this is kept inside my Docker Hub repository. I'll be fetching now. I'll be introducing Docker Hub to you also. I'll be fetching the image from the Docker Hub, and I'll be deploying this for you guys. Okay, so I will need more half an hour if you guys are okay, because I don't want to keep you guys hanging in between with this thing. Do you have half an hour? Can we continue this topic? It's already 8:20. I think more 20 minutes is what I require to show you the complete flow, set up the complete flow for you guys. What do you think? Do we have half an hour, or do you want me to do this tomorrow?
Do you mind if we do it tomorrow? I feel like we have a lot to catch up on and practice and absorb in a way.
Perfect. That works.
Yeah.
That works. That works, babe. So this is more half an hour. Again, Istio doesn't have much command line things to do, but yeah, how do we have already seen how do we download Istio. Now the only thing is remaining, we need to go and set up these applications. Okay, once these applications are set up, I'll show you how Istio get injected. Once the injection is done, then the rest of the things are with monitoring. We'll go to monitoring, we'll install Prometheus, Grafana, Kiali, and there are n number of monitoring tools what we will install, and post that we'll start monitoring. Like after that, it's all about monitoring, that how the network is flowing, how the traffic is flowing, how the things are getting encrypted. This is all about monitoring post that. Okay, that's good. Let's wait and let's continue this topic tomorrow, because if I go and set up this for today, there are so many tools will get involved: Docker Hub, Docker, Kubernetes. So you all will get confused. So this is very advanced, guys. Frankly speaking, very advanced. I'm not expecting you guys to know it from day one, but at least keep it keep in your back of your mind there is something called service mesh, and how that service mesh gets integrated with microservice world. That is something you need to keep in mind. Why do we have service mesh? Just to make sure the network traffic is encrypted. The inbound, the outbound traffic which is coming and going inside from your pods, those should be encrypted. Just keep that in mind. Okay. So that's it for today. If anyone any question, last minute question, please do let me know, or else we can wind up and we'll set this up tomorrow. Okay. Anyone? Any questions? Any doubt? Nothing? Thank you very much. Let's meet up tomorrow and let's continue with the topic Istio. Bye bye.